You ever heard of ammonia as a refrigerant? Yeah, it's a good refrigerant. You can have it. We don't have it in a lot of homes. But I've covered up something, some keywords here. And you could have ammonia refrigeration where you have a condenser. Does that look familiar? Sure. An expansion valve. That looks familiar. Sure. Evaporator. What did we cover up? The compressor. But you know the cost of running that compressor is high, and engineers have looked at ways to reduce the cost of running air conditioning systems. And so they've come up with an absorption refrigeration system. But you still have to achieve the boost in the pressure. This has to have the ammonia coming out. Typically it's superheated ammonia at high pressure. Right? That's what you really need. And you need a line right here to draw in at low pressure some vapor, saturated vapor, typically or slightly superheated vapor, ammonia. So what did the engineer come up with? The creative engineer come up with that he named it the absorption refrigeration system that's covered up here. It's just a compressor, but it's a compressor that's not going to consume a lot of work. Well, we have two devices to boost the pressure. A pump and a compressor. Pumps work on liquids. Compressors work on gases. The compressors are expensive for the same delta P. What about the pump for the same delta P? They're cheap. They're very, very cheap. It doesn't take a lot of work to boost the pressure of something that's nearly incompressible, like a liquid. So guess what they have to do? They have to take this ammonia, NH3, which is low pressure and cool, and get it into a liquid state. Then boost the pressure. You're saying, how am I going to get that ammonia into a liquid state? Water. What? This is crazy. First time you hear it, it is absolutely insane. How does this work? Well, it's a little more complicated, but they take water and they cool the water, and they don't have to cool it that much, and the ammonia will absorb into the water. The gas will go into the liquid water. And you'll have what they call a strong solution of ammonia in the water. You don't want to drink this. It's a strong solution. But now you put it through a pump. There you achieve your pressure increase. But you did this with water going along. I need to get the water out because I need pure refrigerant, ammonia, to go through the condenser and all the way through. So then they think, oh, if I have it a warm solution, what naturally wants to come out now? The ammonia. It wants to not be dissolved in the water. So you have basically, you heat it up with some side heat, don't have to heat it up that much, and you have a generator which basically separates the ammonia, drives it off. And now I have a weak solution, meaning not a lot of ammonia absorbed in the water. I drop the pressure, just use an expansion valve to drop the pressure, and now I'm down, ready to make the loop. So keep the water here, and the ammonia goes there. They have more complications to make it more efficient because this strong solution's coming in cool, and you're immediately going to heat it up, and this weak solution's warm, and you're going to be trying to cool it, so why not what do you think they're going to put right in here? A heat exchanger. Yeah, it's a regenerator. It's really hard to get the pure, you don't want any water going over here. So they have something to help make it more pure, a rectifier. And these systems get more and more complicated, but the key idea is the pump replaces the compressor to boost the pressure. I see you're a little antsy. Thank you very much.